So welcome, everyone. Today, we'll chat a bit about what it means to extend the functionality for Aragon DAOs, and what is this protocol that we've released so that we can understand it better in its architecture and its processes, and then build upon it. So firstly, let's talk a bit about what even is Aragon OS X. As you may know, Aragon has been in the market since 2017, and back in the day, we started with our own products and a different protocol that we've recently stopped maintaining, and now have focused all of our energy and resources in this new stack that we've released. And so when we think of what is Aragon OS X at like a higher level, it really is just a DAO framework. It's a protocol that enables you to create, manage organizations on chain. Now, if we look a bit at the architecture, I think it's important to note that one of our key lessons from our previous stack was that it was overly complex. There was a lot of matching, a lot of moving parts. And so really for DAOs to be customized to fit the needs of the ever-evolving market of today, we needed to take it back a notch and make sure that our protocol was as simple and lean as possible. And so this is the conclusion that we've reached. If we look at the overarching architecture, we really see these two key sections play their roles. And I'm going to start with the core contracts specifically. So the core contracts are essentially those interfaces that the end user will really be dealing with. Right, so this is the DAO contract. The DAO contract is the one that will hold all of the assets for DAOs. It's the one that acts in many ways as like the vault or the treasury or of the organization, and the one who's also managing the permissions and the permission library that DAO has. So what we mean with permissions is essentially how we've set up our architecture to protect malicious actors from being able to do anything everywhere and steal our DAO's assets and perform funky stuff with the DAO as a whole. And so permissions are a kickback hash, which enables you to perform X action on X plugin based on the permission that function has. We'll see a bit deeper what that means when we get into the demo. But that's essentially the DAO interface. And then the other key interface that we have are the plugins. If we go into the contract specifically, and we will in a second, we'll see that inside of this plugins folder, we really have all of the base templates for the different types of plugins that we see people building. Now we have non-upgradable plugins, upgradable plugins, clonable plugins, and we'll see different types. But essentially, what we're building there is a base template so that developers can simply build on top of it, and we take care and abstract away some logic to make that development easier and faster. Now, like I said, these core contracts are the foundation, right? This is what anyone and the end users will actually be seeing. But in order for these two sections to behave accordingly, they really need the framework that powers them. And so the framework, we can imagine it as kind of like the creation factories, the registries, the installers. It's all of the services that like the backend sort of section that empowers the interface to live to its full potential. So when we look at our framework contracts, we also have them divided by DAOs and plugins. If we look at our DAO section, we have our DAO creation in terms of like a DAO factory. And we also have a DAO registry so that we have a registry of all of the DAOs being created in the protocol. Then if we dive into plugins, we have the plugin factory, similar to the DAO, enable us to create plugins. We have the plugin registry. And then we also have the plugin setup processor, which you can understand is kind of like an installer of a plugin into a specific DAO. Now, I want to stop here for a second, because particularly when you talk about plugin management, there's some nuances that are very interesting to know. Starting off, when we look at the creation of a plugin, we're really seeing the name plugin repo factory. And this is interesting because I'm speaking about plugins, but then the factories for a plugin repo, what does that mean? And what it means is that a plugin can have several versions within its lifecycle, right? So we can imagine that we release one version for the initial plugin, and then as the plugin evolves, we want to release more versions. And so when we're speaking about a plugin repo factory, what we're really saying is that when we create our first plugin, we're creating the first plugin repo, which is the one that will contain all of the versions from there on forwards. Then when we look at the registry, again, what we're storing is not necessarily the plugin itself, but we're storing the address of this plugin repo that we created in the creation so that we have all of the versions within the same space. And then when we're speaking about the plugin setup processor, we're really installing this specific version into a DAO. Now, when we speak of installing, and this is where it all connects with the permissions that I was mentioning earlier, installing is really just granting permissions for the DAO to execute the plugin actions. And so we're going to see in practice what that means, but it's an important concept to grasp because really what is connecting everything together is the permissions that each contract or each person has to execute actions across the DAO. Now, let's look specifically into what an Aragon DAO is to get a bit of a visual of what we're playing with. Again, if we look at the DAO instance specifically, we have the DAO.sol contract. This contract has permissions, for example, to deposit funds. Again, I said it acts a bit of like a treasury or a vault. But more specifically, it contains the execute function. So the execute function is the function that gets called whenever we're executing actions on behalf of the DAO. And we can see that it has two key parameters. One is the auth authentication parameter. This is a modifier, essentially checking whether the address that is calling the execute action has the permission to call it. And then we have the action, which is the actual action that we want to implement. And this will become important later on. And then, of course, each DAO will have its own permission library with the different permissions that it can implement, it can use. And then we have, of course, all of the plugins. And I think what is interesting about this visual is that it really exemplifies how our protocol is only a permission management system and a vault. And then everything else, every functionality that the DAO can do is based on plugins. And this is why plugins are really the key and the center of what DAOs can do, because this is how we're extending any functionality that DAOs will be able to use to interact across the ecosystem. Now, we have this kind of like green circle around it. And what this means is that this is one DAO, and the way in which we're interacting with it is through its interface. This may be through the Aragon app. This may be through a CLI in my terminal. This may be through another custom UI that I've built, but there is always an interface through that I'm using to interact with the DAO, and then I can extend functionality through my plugins. So when we're talking about how to customize an Aragon DAO, we're really looking at these two key sections on how to do that. And throughout the rest of this workshop, essentially, I'll be going through each and taking you through how we can extend functionality for DAOs and ultimately build the custom organizations that we want on chain. So let's start with the meat of this. What are plugins? And actually, before I carry on, do we have any questions in the chat or anything coming up about what I've just shared? All good? All right. Feel free to share any messages there. Just raise your hand, and more than happy to go through some of these concepts. All right. So what are plugins? When we're thinking of plugins, you really are always thinking about these two contracts. Every plugin will have these two contracts. On a first level, we have the plugin implementation contract. So this is the plugin. This is the implementation and the contract that will contain all of the logic that that plugin can do. So if you are building a governance plugin, if you're building a finance plugin, all of that fun functionality that the DAO will be able to do will be stored in this plugin contract. And you can, of course, from that one, deploy any other helper contracts that you may need. But this will be really the base for the implementation and the functionality extension that you want to provide. Then the second contract that we have is the plugin setup contract. And the plugin setup, it doesn't contain any of the logic. What it contains is the installation instructions. So the plugin setup contract is the one that plugin setup processor that we saw a few minutes ago is going to grab and use to install that plugin into a DAO. This is what we pass in any of the parameters that we need, and where we structure the permissions that are needed in order for the DAO to interact with that plugin. And Luis, yes, no worries, I'll share the slides after the presentation, along with alongside a cute little tutorial I built. Now, how are plugins published? Right, so we have a plugin, say we deploy it, we put it out in the Ethereum blockchain or Polygon or whatever it is you're into these days. And then how does that get actually published into our protocol? So the first thing that we'll want to do is that we're going to want to call the plugin repo factory. Like I said, this is the factory in charge of creating these plugin repositories, which will contain all of the versions for that plugin. And really all it is that we're going on, it could be even just Etherscan, going in and calling on the create plugin repo with first version and passing in our plugin setup address that we've deployed. Once we do that, the next thing that's going to happen is that this will deploy a plugin repo for our specific plugin that we've just added the address here. And that's what will contain all of the versions and where we'll be able to keep creating versions as time goes through. Now, once that's out and published into our protocol, how does that then get installed into a DAO, right? From that point forward, the plugin is out. We'll be able to see it in our subgraph. We'll be able to interact with it across different ways. And so now we're looking at how to install that extended functionality that we've built into our DAO. And what we're looking at there is the plugin setup processor. The plugin setup processor, like I said, is the installer. And what it'll do is that it'll apply installation, it'll apply on installation, or it'll apply an upgrade of your contract if that's what you want to do. And so this apply installations will take in a specific prepared set of data attribute that we'll see when we go into the demo, and it'll grab that prepared installation that it's compiled from the plugin setup, and it'll essentially use that plugin to install it into the DAO. Now we're going to see this end-to-end flow, but I really wanted to provide kind of this visual so that you have a mental mapping of what we'll be tackling on as we move on. Now, I think it's important to know and tackle into what are some plugin examples. Ultimately, the real answer is anything could be a plugin, at least in terms of how we've structured our protocol. It's quite open. You may inherit from the base templates or not. You may follow certain standards or not. Really, it's all up to you. But I think there's some patterns that we've started seeing as to what usually are the plugins that DAOs are needing and where they should go. So firstly, governance plugins. DAOs need to make decisions. And so if they're making decisions, governance plugins and decision-making plugins are a great way to do that. Secondly, coordination functionalities. So looking at bringing on some autonomy to different guilds or groups within organizations. This involves potentially sub-DAOs, team permission management, coordination graphs, you name it. Then we are also looking at treasury management tools. So if we have X amount of assets, I'd like to stake these, add this into a liquidity pool, get whatever type of yield I'm looking for across platforms. And so certainly that connection between the DAO's treasury and any type of fun treasury management tooling and logic could be a great plugin. And then lastly, these action bundles, right? So maybe I want to set up a specific type of logic to distribute tokens. And then once they're distributed, perform X action around. And so we're looking at these bundles that grab a bunch of different actions from around the ecosystem, from around plugins, and essentially build those bundlers for you. Now, equally as important as what to build is what not to build. Again, like I said, in practice, everything could be a DAO. So nothing is stopping you from building these types of plugins that I've laid out here. But I think it's still interesting to think through why they may not be best suited to be a plugin. So number one, information fetching. In reality, you could do it, but it is essentially not practical or needed. All information is out on the blockchain anyway. We have a subgraph, we have an SDK. You probably don't need a plugin simply to get information from the DAO that's public anyway. And then connections with other contracts. Certainly within your plugins, you could call on contracts from around the ecosystem, but it'll probably be easier just through our interface or through bundling actions to call in those contracts. And so they're not necessarily the ideal use case for it because there's other simpler ways to do this. Now, having that said, let's go into the demo. Any questions before I dive into the code? All right, cool. So we are going to go into my terminal. Let me move over this to this screen. Of course, I bet this is too small, so let me make this bigger. All right. So I will firstly create a template, a folder. Let's call it DAO Global Hackathon Workshop. And then what we want to do, let's move into that folder. And then the first thing that we'll want to do is, of course, make sure that you actually have Hardhat installed. If you don't, you can go ahead and install it. And I'm going to share here the instructions on how to do that. Now, once we ensure that we have Hardhat installed, I have it, so I won't dive into how to do that. Then we're going to go into how to create a new Hardhat project. And let me share this here as well. And I'll also share a link to the tutorial that I'll be following in case you want to follow along and use it out later. So first things first, we go in. We do npm init. As you may know, for those of you who are JavaScript engineers in the room, so npm init, all it does is that it's creating us a package, the JSON file that will allow us to start installing some packages and building out our repository. So package name, let's call it that. Let's just make it easy, all of the defaults. And if we go inside now, we have a package.json file. If we see what that package.json file holds, it is essentially a JSON with the parameters that I've just set up above. Nice. So next step, after we have the folder initialized, we want to install Hardhat into it. Now, by installing the Hardhat package in here, it will allow us to then be able to generate a Hardhat project, which is how we'll start building our plugin. This will take a bit. So as we move forward, let me just take you through a bit of what we're going to do. So we're going to go and call in the Hardhat function that will essentially generate us this empty Hardhat config file. So for those of you who may be new to Hardhat or Solidity, the Hardhat config file is how we set up the configurations for our Hardhat environment to run, as well as any configuration that we may want to use if we want to go into another environment, like say Mumbai, Gurley, Mainnet, etc. So we have this done. We call then in this npx Hardhat command. We create a TypeScript project, set up the root. We want to git ignore. We want to use the Nomic Foundation Hardhat toolbox, and that'll generate the project for us. If you're intrigued, the Nomic Foundation Hardhat toolbox is a set of plugins that the Hardhat team has built so that we can speed up development. It includes certainly like a smaller template. It has some deploy function. It has a base contract. So it's essentially a way for us to have already some foundations laid out for us to begin the fun. And now that our hard hat project is created, we can go ahead and check out our VS Code and start playing with it. So let's do something. All right. Now, so if I go into my hard hat project, I see that I have a contract. Again, this is a contract that they've set out for us. We have the deploy script, which deploys that contract that they've laid out. We also have our hard hat config file, which is that environment file that I was telling you about earlier. We have the package JSON that we set up when we first started, as well as the packages installed and a TypeScript configuration so that we can use TypeScript within our project. Now, because we're going to be using these base templates from Aragon to build our plugins that I was telling you about earlier, then really the next thing that we want to do is that we want to install the Aragon plugin package so that we can have it within our project. So I'm going to go npm install Aragon OS X, and that'll bring me or enable me the functionality to call into our contracts throughout our project. Now, to give you some context, what we're going to be building is very simple plugin. It's just going to be, your classic hello world type of plugin where we're going to set up a greeter that returns hello world. Now, through doing this, we'll be able to see the structure of a plugin contract, the structure of a plugin setup contract, some best practices and things to keep in mind, as well as go through the deployment script. And if we have time, ideally also set up a Goerli deployment. So now that we have their packages installed, we can get ready to play with our greeter contract. So I'm going to delete this one for good measure. And I am going to create a greeter plugin.sol contract. Now, like every time we play with Solidity, first thing to do is to add in the license. So I will go in and simply copy the license there so that we have it. Perfect. And then we want to set up our Solidity version, which, that it should be, I think, more like 17 is the latest that we're at. Or actually, that should work out anyway because we have the little thing up top. Don't mind me with the VS Code. I've been looking into how to solve this problem. It's a VS Code problem, so it's actually a Solidity problem, and I haven't been able to sort it out. I've been reading some docs, but if you have something to share, please, I'd be happy to look into it. Anyway, let's get started with the fun. So first thing we're going to do is that we want to start our contract called the greeter plugin contract. Now, this contract, we want to be using the base templates from Aragon. So we're going to go and say that the greeter contract, the greeter plugin is a plugin contract. Now, if we're going to be using the Aragon plugin base template, we have to import it. The best way to check how to import or what to even import is going into the GitHub repository for OS X. And we're going to dive into packages. We're going to go into contracts and source. And from here on forwards, this is the path that you'll follow to get your addresses to import the code. And I've just shared in the chat the access to this specific GitHub repository. So we want to tap into the plugin. Now, where do you guys think this plugin folder and base template will be based on that image that I showed earlier? Any ideas? Feel free to put them in the chat, raise your hand, do all that fun stuff. Any ideas? All right, guys, no ideas. Well, here, if we're looking at where we are within our architecture, we'll see that because the plugins are an interface that end users are dealing with, we'll find our base templates for plugins directly within our core contracts folder. That means that if we go into our GitHub, we're not going to go into plugins. Plugins here is a combination of the plugins that we've built for the protocol already. So it's a great place for inspiration if you're looking to build your own plugin. But what we want to be going is into core, then dive into plugin. And here's where we'll find all of the different base templates for the types of plugins that you may want to build. Now we have different types. Today, we're only going to go through the most basic one. And so if you see the template, it is still quite lean. There's not much to it, but what is there will help us abstract logic in a way to ensure its safety and to ensure that we're interacting with the plugin in the right way. So we'll have the most important thing to know is that within our constructor, we're setting up already the DAO that this plugin will be interacting with. This eDAO interface is a DAO interface that we've laid down. And so it'll allow you to use this DAO and have a getter DAO function within your plugin as you're playing with it. The other important thing to know is that it has a DAO authorizable. This DAO authorizable imports that auth modifier that I was speaking about earlier. This is the auth modifier that ensures that only the addresses with a specific permission are able to call on that function. So let's call that in within our contracts. We're going to be importing plugin from Aragon OSx core plugin/plugin.sol, right? According to what we have here. Very nice. And then we're going to go inside of it. And the first thing that we're going to do is set up our permissions, right? So the first thing that you always want to do with your plugins is define the types of permissions that you'll need for your plugin to run safely and correctly. So we're going to create a base32 public constant variable called greet permission ID. And this will be a kekak 256 hash with the greet permission string inside of it. Now, once we have this done, the next thing we'll do is, of course, create our constructor. Now, this constructor, like we saw earlier, takes in a DAO instance and is using the DAO from the plugin that we've imported earlier. And then we're just going to create our basic greet function, right? So we have a function greet, which is external. It's a view function, so it doesn't change any of the state of the blockchain. And then we're going to call in, oh, beautiful ChatGPT. And then it's going to create it's going to use the authorizing modifier that we were speaking about earlier, which defines that only addresses with the greet permission ID are able to call on this greet function. And then this is just going to return a string, hello world, and we call it a day. So currently, as we have it, this is our plugin, right? Nothing too complex, but it shows how we're able to have a DAO. We're able to use it, by the way. So if you wanted to do DAO and call on any function from the DAO, you'll be able to have that instance thanks to us importing from the plugin-based template, and we'll be able to use it throughout our functions. Now, important to know as well that actually this template also grants us access to an interface of a DAO so that we are able to call it throughout our work. Nice. So now that we have our plugin, what's the next step? If we look at our slides again, we'll see that every plugin also needs its plugin setup contract. So the next thing that we're going to set is the plugin setup. So I go into my contracts, new file, greeter, plugin, setup.sol, and we'll go through a similar version and licensing. And we're gonna first define our greeter plugin setup contract. And this time, rather than calling from the plugin contract from our packages, we're gonna be calling from the plugin setup contract and base template. So again, if we're calling from this, then we have to import it. In this case, because the plugin setup is a part of how we're implementing and really installing our plugin into the DAO, we'll be seeing it within framework, plugin, setup, and then we have our plugin setup. So this means that what we want to import is something like plugin setup from Aragon OS X framework, plugin setup.sol. Sweet. Now we're inside. So the first thing that you'll want to do, again, we're importing from the plugin setup. And so this means that we already have a bunch of functionality that we should be able to see. So I can show it here. Maybe this is a bit small. And so essentially what this is doing is that we will have some functionality to use. We have a prepare update, which prepares the update for a plugin to be updated. We also have this proxy and supports interface. These are all for the upgradable plugin, which means that for us, essentially, we're inheriting the plugin setup and not much more aside from that. Now, within our setup contract, we want to be doing is calling on the prepare installation and the prepare on installation functions. I think this is very cool to see in practice, in the sense that it'll give you better ideas as to what we're doing if we look at the code for the plugin setup processor. So as we can see, the plugin setup processor expects a prepare installation that it will then apply. And so what it applies is to a DAO the certain parameters that have been passed in the prepare installation function. And that's really what we're going to be doing. So we're going to be adding here a function called prepare installation, which takes in the address of the DAO we want to install the plugin into, as well as a data attribute in case we want to pass in some call data when we're preparing our installation or creating our DAO. We don't really need this in this case because we're not passing in specific parameters to our plugin creation, but it may be super useful later on, and the plugin setup expects a parameter to be passed there. And then we're going to define the attributes of this function. So it'll be external, meaning it can be called by external contracts. And then we're also going to be passing in the address of the plugin that we want to be installing, as well as, we're going to be returning the new plugin that we've prepared, as well as the prepared setup data, which is a interface defining the type of return object that we're going to be returning. So let's call it prepared setup data. Now, because we're defining it here, that means that, of course, we need to import. And if I'm not mistaken, within our plugin contract, we should have imported already, which means that we don't need to do the importing ourselves, which is really nice. Yeah. All right. Yeah. Cool. So let's dive into the implementation of this function. First thing that we want to do is deploy our plugin. Now, this is key because if you're looking at, again, our slides from the presentation, we'll see that really what the plugin, the attribute that the plugin repo factory takes is the plugin setup address, which means that from an Aragon protocol perspective, all we have is the plugin setup address. We don't have the specific plugin implementation. And so the plugin setup contract is the one in charge of deploying that plugin implementation for the Aragon DAO. So first thing we want to do when we're speaking about installation is go ahead and define that the plugin equals to the address of the new greeter plugin contract, which is a DAO as defined in our interface. All right, now that we have our plugin address, then we want to start playing with adding in the permissions to our DAO to be able to interact with this plugin. Again, going back to that comment I was saying earlier, when we're speaking about installation, what we're really speaking about is about granting these permissions. So because we're using the greeter plugin here, we're going to have to install it above so that it has access to the greeter plugin. So beautiful. So the first thing that we want to do is that we want to be tapping into the permission library of that specific DAO. Remember I showed you earlier and that each DAO will have its own permission library, which defines the permissions that that DAO can interact with. So we're going to call in the permission library of that DAO. We're going to import it in a sec. And from that permission library, we want to be setting a multi-target permission, which will be stored in memory as a multi-target permission type, which will be stored in memory as a permissions array filled with permission library multi-target permission types. And it'll only have one storage since we only have one permission set within our plugin. So through this, we're essentially setting up the storage space so that now we can fill it with the actual information that we want. So I'll go ahead and I'll call on this new array that I've created, go into the first location, which should be the only one that we have. And I'm going to call on the permission library, multi-target permission to create a new object of this type. And inside of it, we're going to take certain parameters that are key when we're defining permissions. Firstly, what do we want to do with that permission? Do we want to grant it or do we want to revoke it? And in this case, because we're speaking about installation, we want to grant it. So we're going to go into operation, permission library, operation, grant. Then the second thing that we want to do is define where that permission has access to, right? Where does that permission even matter, right, across the contract world? And so when we're looking at where, we're really speaking about our plugin contract, right? That's where this permission can take some action. Who can use it? The DAO contract that installs the plugin. Does it need any specific condition for running? No, it can run without any conditions. And then which permission are we actually talking about? And this is where we tap in again into our kickback hash with our greet permission string, enabling us to access our permission. And once that's done, we see that we need to return the prepared setup data variable. So all that we do is we call the prepared setup data variable, and within it, we'll have an array called permissions, which is now filled with the permissions we've laid above. Now, when we're looking at the uninstallation function, it's actually quite similar, except rather than granting, we're revoking. So we'll call in a function. We'll call in a function called prepared on installation, which takes in the address of the DAO. And it also will take in an additional type called the setup payload, which is the payload passed whenever we want to uninstall a plugin. This is how we'll be able to get the plugin address as well as any other data that you may be wanting. And it's quite similar to this variable there, which is here, which we may also tap into in the prepare installation. And then again, we define the attributes of our function. It is external, it is pure, and it returns a permission library multi-target permission which should be stored in memory, and we can simply call it permissions. So this, oh, fuck. Oh, wow, quite nice. Yeah, so basically, Copilot will do it for you. So we'll see here that we have, and we probably just need to close it so that it's well done. Yeah, amazing. So what we have here is that we have, rather than having the granting operation like we had above, here we have a revoke operation. Where is that the action, what is that permission living, or where does it give you access to? Well, we'll get in the address of our plugin directly from our payload. Who is able to interact with it? The DAO. This is the address that's getting the permission revoked. Which permission? No condition. Permission ID, the same permission ID that we passed above. And with that, we have our installation and our prepare on installation functions ready to pass on over to this plugin setup processor to grab this information and install your DAO, your plugin into your DAO through applying the permissions that we've set here. Now, the last thing that we want to do is that we're going to create a implementation function, mostly because this is a function that is expected from the plugin base that we've imported. This may be used later on for different use cases, but if we don't import it here, we'll get a abstract error and then we won't be able to deploy our plugin, which sucks. The other thing to check is that here we're calling a bunch of times the permission library, but we're not really using it. So that means that, sorry, we're not really importing it. So that means that we need to import it. And again, in order to know where that lives, we'll go directly into our contracts. And if we look at the graph here, we see that the DAO is the one containing the permission manager. So I'll go into core, I go into DAO. Sorry, I go into DAO and I see my permissions. And then here's the permission library that we've been chatting about. You can take a look into it. It essentially sets the type of operations that we can do with each permission that we're setting, as well as whether that condition is a single target permission or a multi-target permission. Single target permission will save you gas, but ultimately the multi-target permission is a more generic one for most use cases, which is why I've chosen it here for you to take a look at all that you can actually do. So we know that this is where we have to import our permission library from. So we'll go ahead and import permission library from Aragon OS X core permission library dot solidity. This is good. All right. So with this, we should be done and ready to go for our plugin. I'll stop here in case anyone has questions in terms of how we're just building the plugin. Now we're going to go into the deployment and publishing of the plugin itself. All right. Well, going into deployment, what we want to be doing is that we firstly want to create actually we don't need to create a deploy file because we already have it. The hard hat project created it for us. What we do want to do though is delete the current implementation there and create our own. So firstly, we'll go ahead and we'll define who the deployer is. In our case, we're getting the deployer directly from the ethers package that's a dependency from hard hat. If we don't define our network, we're simply going to be using hard hat's local environment. So they'll give us a deployment by default, which is great. And then we're going to set up some console logs so that we can track really what's happening. Number one, defining who the address of that deployer will be. And secondly, let's check out also how much money they have to track how much the deployment costs. Then the next step is to actually call on our functions, on our contracts and deploy them. So like we said earlier, we only need the plugin setup contract to deploy the plugin setup address to be able to deploy our plugin. So that's the only one that we'll deploy, and the plugin setup contract within its implementation will take care of deploying the other plugin that actually contains the functionality. So I'm going to go ahead And I'm going to first get the greeter setup contract through setting up a permission, yes, which goes into the contract factory and gets the plugin with the name greeter. In this case, it'll be, sorry, with not greeter, we'll need a name that is greeter plugin setup contract, which will get it from here. Once we have this greeter setup contract, exactly like what Copilot is telling me, we're going to define it and deploy it. Then we'll wait for this greeter setup contract to be deployed. And then we'll ultimately just display on the console a little message saying like, hey, I have been deployed and this is my address, right? So with this, we should be able to already deploy our contract into the hard hat local environment. So let's go ahead and run npx hard hat run scripts deploy ts. And through doing that, we're seeing some problems. It's a versioning problem, so I probably need to change my version here. I have 2.8.17, and here I have 0. That shouldn't be a problem, except for the compiler telling me that they should be 8.17. So we're going to go ahead here and define that, and we're going to run it again. And then we're getting different types of errors. So expected, but I got coma, so I must have missed some random. Oh, here we go. Missed some semicolons. Let's try again. All right. So we're getting this problem here. Oh, yeah, because this gets defined like this. Nice job. Now let's try again. Contract, greeter plugin. So same thing happening here. And in the so prepare to set up data. It's not being called. So let's go into the setup contract. Prepare. Oh, it's because I used a different name. Classic. All right. Let's see. Prepare to set up data. What's the problem here? Oh, the problem is the semicolon here. Amazing. Returns. All right. All this good stuff. Declared an identifier. Oh, typo. Classic run. So it was throwing me this error in here. Amazing. And now something else should be marked as abstract. So the reason why this is telling me that it should be marked as abstract is because I am missing some implementation. Here it says that I'm missing implementation from the plugin setup contract for the prepare on installation function. So if I go into the prepare on installation function, I am returning exactly what I need. I have the permission library, permissions, disclosure at 0. And then we should be returning permissions, but it's already by default. So let's see. No, that wouldn't make sense. No. Let's see. So relevant source part starts here and spans across multiple lines. Oh, so potentially there's something I'm missing. Should be marked as abstract. That's not true. Here we go. So usually what it'll do in this case is it'll check out the plugin base that I'm importing from. So let's check out framework, plugin setup, and I see that I have the implementation contract, which I should be able to call merely with no. Let me check my notes. 1 second. external reviews return and an address. I go into another project that I've done. Let's see, maybe there's something I've forgotten or missed that needs to get added to ensure that we don't have an abstract contract. Implementation, this should work fine. We have all of the on installation plugin set up, and we have this returning, which makes me think this is not needed. Why is it returning? Operation failed. Control respect to missing implementation. Function prepare and installation. Relevant source bar. It starts here and spans across multiple lines. All right. Well, I will take a look. Either way, we shouldn't need this for deploying our contract. So we can go ahead, look at it, but it's still marking as abstract. I'm not sure what I'm missing. The plugin setup, plugin library is a plugin setup contract. Bytes in memory, semicolons, returns. All right, we're in. So now this means that we've deployed into our local hard hat environment. Firstly, the account that was the deployer of this contract, then the account balance that this address has, and now we have access to our plugin setup contract being deployed. Now, because we're currently running on a hard hat environment, this means that we can't just use this address to deploy to publish our plugin into our protocol. But either way, I'm going to show you how you would do that if you wanted to, because it is super simple to map out. So we'll go into, again, our contracts and our repository. And here we have an active contracts JSON. This active contracts JSON contains all of the addresses that our protocol has active across the different networks. And so what we want to do is we want to go into the plugin repo factory contract that we saw earlier, go into the network of your choice. It could be Etherscan. You could also just do this, by the way, through a script, but just for the visualization of today's workshop, I want to show it to you through Etherscan. We'll go into the address. We'll go into the address. And now we're inside of that specific plugin repo factory contract. We go into contract, we want to write, and we see that we have two key functions here. One of them is the create a plugin repo, and the other one is create a plugin repo with the first version, which is the one that we'll be using since this is the first version of our plugin. So we'll do a subdomain. This will be a greeter plugin. We'll pass in the greeter setup address that we've set up here. We'll pass in a maintainer address, which will be, say, in this case, whoops, I don't have it currently I don't have MetaMask updated in that specific browser. Let me get an address. Anyway, you would get your address here, whatever it is, your address that will be the deployer and the maintainer of that plugin. And then on release metadata and build metadata, this is something that you want to keep in mind, considering new versions of your plugin and how those plugins will be interacting with the front end and the framework itself. But for now, we can just say like passing a hex string and leave it at that. And if we connect to Web3 here and write, we'll be able to publish this plugin into the protocol. Again, because I didn't deploy to Goerli, I just deployed to a hard hat local environment. This won't work. But keep in mind that as long as you once you deploy this address to Goerli, you'll be able to do that. And within our tutorial, you'll be able to see how to deploy it on Goerli. Now, last thing I want to show is how to check that that's done. So I will send over the SDK environment variables that we're currently using. This is so we can see all of the different addresses. Oh, I lost the chat. One sec. Nice. Oh yeah, I'll tell you how to solve it in a sec, Adam. So once we have the this Notion doc that I've shared, you'll be able to see all of the different addresses that our current protocol has, because we're deploying this, in this case, on Goerli, would essentially go into our subgraph here, and we would pass on a specific query to get all of the plugins deployed into our environment. So what we can do is we'll pass over this get plugins query, which should get all of the plugins that are within that blockchain. And we see, for example, I was playing with this earlier, we have the Greeter plugin trial deployed, and there's also a bunch of other ones that have been deployed into Goerli. So that's kind of all that I wanted to share in regards to building a plugin. I see that we're right up on time, so if anyone needs to leave, feel free to do so. But I'll be taking any answers if you guys want. I also had a bit of a rundown of how else we could customize it, but considering time is done, I'll share with you the slides, and feel free to take a look at that later on. I don't want to take up too much of your time. So I will share this. Let's make it anyone with a link, copy a link. Here you go. And so looking at how to solve the abstract issue, it seems like the abstract issue is coming because there's one of the functions that our plugin setup based template expects, and it is not finding the implementation within our contract. So let me update the Notion tutorial so you have access to the right work. I think that's where the error may have been coming from. Yeah, so I've already updated it. You should be able to see the new implementation there. I'm thinking it's probably just Go pilot as it came out with a solution. It may have missed a specific point or something, and that's why that happens. All right. Any other questions, guys, that I can answer for you? Cool. So we're out of time. Please feel free to message me, hit me up if you're building with us. I'd love to hear what you're building. I'd love to support you in however I can. Some of the bounties that we have set up for this hackathon are looking at the best governance plugin. We're also looking at the most creative use of the protocol. We'll be looking at a best quick starter dApp to get DAOs built on Aragon super quick and for different use cases, and essentially bundles of plugins that may serve specific niches, verticals, and then a permission management dashboard. As you can imagine, things get more and more complex. There will be a lot more permissions that DAOs will need to handle. And so we're looking for, a project that can help visualize a lot of these permissions that the protocol will take on. Thank you very much. The last thing I'll leave you with is this little graph that we didn't have time to look into, but what we've discussed here is merely the protocol aspect of extending functionality. But within our stack, we have all of these other three entry points in which we could customize and extend functionality for DAOs. So we have the subgraph, which is how we're indexing all of the events that our protocol is emitting in a way that you can fetch them faster than just trying to query the entire blockchain ledger, which may take a lot of time and it's not user-friendly for the customer. The SDK, which will allow you to plug in the functions from the protocol and use them within your UI in a fast and efficient way, as well as just building a front end through these tooling. I'll share in our Discord chat and channel not only all of the resources that I've shared today, but also our documentation and all of the resources that you can access in order to build this. And please feel free to hit me up. I'm in Discord too often, so happy to support it anyway. Thanks, guys.